Hey guys, Mr. Riz here to help you out on the second day of the 2.4 notes in calculus. So today we're going to keep using the chain rule. We're also going to apply the product rule and quotient rule with it. So some of these we just got to be careful of. When is the chain rule being applied? Is it being applied at the beginning or is it being applied in the middle? So we'll just take our time with this. So this first problem here, we have x squared times radical x minus, or 1 minus x squared. So you can see we have a 1 minus x squared inside of the square root. So that's the chain rule, but it's also being multiplied by x squared. So that means we got the product rule. And unfortunately, there's not going to be really any ways that we can like rewrite or work our way out of this. We just have to deal with it. The only thing I would probably change is make this a x squared times 1 minus x squared to the 1/2 power. All right, so let's get started with this. Let's do the chain rule. So I'm going to do a couple things so you guys will see over time, repeated habit. These processes will help you out. So first part, let's do the chain rule. Let's take the derivative of the x squared, which will be 2x. We'll leave the 1 minus x squared to the 1/2 power alone. All right, then next plus, we'll leave the x squared alone. We'll times by the derivative of the inside. Now, since the derivative of, or the second part, since the derivative of the second part has to use the chain rule, I always like to use like these braces here. They just help me keep things separated. So the chain rule says it's going to be 1/2 of that something to the negative 1/2 power. And then we got it times by the derivative of the inside. The derivative of the inside, 1 goes away, negative x squared becomes a negative 2x. All right, so let's just double check that you understand the product rule and the chain rule. So product rule says the derivative of the first part of x squared is 2x. We leave the second part alone. Then we left the first part alone. The derivative of the second part we had to do the chain rule of. So now what we need to do is to simplify this. All right, first off, the 2x times 1 minus x squared to the 1/2 power. That does not simplify at all. That's just that. And then plus, okay, we can multiply the x squared. Actually, I'm not even going to put plus there because what's going to happen next? We can multiply the x squared times the 1/2 and then also times the negative 2x. So we would get x 1/2 times the negative 2 is negative 1. X times x is x squared. So we get a negative 1x cubed times 1 minus x squared to the negative 1/2. Now, if you got your answer like that, that's good for right now, but let's practice trying to get a complete answer. So to get a complete answer, what I'm going to do here is look to see what do these have in common. They all have x's and they all have this. So we could factor out an x and a 1 minus x squared to the negative 1/2 power. So if we take away a negative 1, let's first factor out the x. Okay, so this first term here, if we get rid of the x, is just 2. Now, if we get rid of a negative 1/2 power, that's like adding a 1/2 power. So a 1/2 plus a 1/2 would make this go up to the 1 minus x squared to the first power. All right, then minus. Now, if we get rid of the x from the x cubed, that becomes x squared. And if we get rid of the negative 1/2 power, add a 1/2, that would be to the 0, that would go away. All right, so this can become something a little bit simpler. We would have this x would stay on top. The 1 minus x squared to the negative 1/2 power would be a radical 1 minus x squared on the denominator. And then let's see, we would have to distribute the 2 here. This would be a 2 minus 2x squared minus x squared. Or finally, the final answer for this one would here be x times 2 minus 3x squared over radical 1 minus x squared. So keep in mind, it's going to take us some time, some practice to get good here. We're going to keep doing because we'll need to by the end or by the start of chapter 3. But for right now, if you can get this far, that's pretty good. All right, next problem here. All right, x divided by the cube root of x squared plus 2. So if you look at this problem, very similar to the last one. We might want to change this to x over x squared plus 4 to the 1/3 power. So we could do low d high minus high d low. Now off to the side, you might want to do, maybe change this to x times x squared plus 4 to the negative 1/3 power. So both of these problems here, you'll get the same answer. This problem here, we got to do the quotient rule because it's x divided by x, this to the 1/3 power. This problem here, we'd have to do the product rule. It's x times that to the negative 1/3 power. Both of these will have the chain rule inside of them, but either decide. Let's do the quotient rule here because we haven't done an example with a quotient rule. And we'll go through this. So quotient rule says we got low, which is x squared plus 4 to the 1/3 power. And then d high, the derivative of x is just 1. Minus high, which is x. And the derivative of the bottom, we got to do the chain rule of. So 1/3 of that something to the negative 2/3 power times the derivative of the inside. That derivative of the inside would be 2x. All over low, which will become x squared plus 4 to the 2/3 power if we square the 1/3 power. Okay, let's try to clean up the top a bit and see what we can get. Now, if we times this by 1, that's just x squared plus 4 to the 1/3 power. If we multiply this top here, we got x times 1/3 times 2x. So that would be a negative 2/3 x cubed times x squared plus 4 to the negative 2/3 power all over x squared plus 4 to the positive 2/3 power. So if you get this far, that's good. But let's try to see if we can make this better. To make this better, what we have to do here to see, well, there's no number outside that they have in common. But they both have these x squared plus 4s, and the lowest power here is to the negative 2/3. So let's factor that out. X squared plus 4 to the negative 2/3 power. If we factor that out, we're going to add a 2/3 power. So this just becomes an x squared plus 4 to the 1 power. And if we get rid of that, that becomes a just negative. Oh, you know what? That should be x squared. I'm just looking here, that's an x times an x, yeah, x squared. That'd be minus 2/3 x squared. And then all over x squared plus 4 to the positive 2/3 power. So if we want to simplify this to make this better, we can move this negative 2/3 power down to the bottom. And when we do that, it becomes x squared plus 4 to the 4/3 power on the bottom. And the top, we combine the x squared and the minus 2/3 x squared. So that'd be a 1/3 x squared plus 4. Now, that's a pretty good answer there. We could factor out a 1/3 and move that down to the bottom, but I think that's plenty good there. Okay, moving on to the next part. All right, what about this one? We have, all right, 3x minus 1 over x squared plus 3, and this is to the all being squared. So if we look at this problem, we have the chain rule, and inside the chain rule is the quotient rule. So we don't want to rewrite this one. We're just going to have to do the chain rule. So let's take our time with it. Let's do the chain rule. So we got something squared. So the derivative of something squared would be 2 of that something to the first power. And then we got to times by the derivative of the inside to times by the derivative of the inside. We have to do the quotient rule. Yay. So we got low. Let's see. Low would be x squared plus 3. D high, the derivative of the top part would be 3. Minus high, 3x minus 1. D low would be 2x. And all over low, which would be x squared plus 3 squared. So let's clean this up before we start combining it with that. You know what I'm going to do, though, is I'm going to distribute the 2 to the top part here, because technically this is 2 over 1, and make this a 6x minus 2 over x squared plus 3. And then let's work on this part here. Let's distribute the 3 here. We got a 3x squared plus 9. And then distribute the minus sign and the 2x, be minus 6x squared plus 2x over a x squared plus 3 squared. Well, all we can do to really simplify here is to combine like terms, and we would get a 6x minus 2 over an x squared plus 3 times, on this side here, we would have, starting with the x squared, negative 3x squared, and we would get a plus 2x, yep, and a plus 9 over an x squared plus 3 squared. Now, if we want to multiply these two fractions together, we multiply top with top, bottom with bottom. And if we want to multiply the tops, we could distribute here, but it might be easier to make this a 6x minus 2 times a negative 3x squared plus 2x plus 9. Because eventually, if we wanted to find anything important about the top, we would have to factor the top. So there's no point of really distributing all that work when we're just going to factor it in the end, unless something could cancel out, which is highly unlikely. In the bottom, technically we have x squared plus 3 to the first times x squared plus 3 to the second. That just becomes x squared plus 3 to the third power. So if you guys got this answer here, that's great. If you can get it a little further, that'd be even better. All right, do we got one more to go? All right, actually no. So the other thing that we can do, now that we have the chain rule with the product rule and the quotient rule, is we want to make sure we can also apply it. So anytime we want to find the slope at any given point, all we need to do is take the derivative and plug it in. So this is something we've done with product rule, chain rule, every rule so far. We're just going to do it, well, we haven't done it with chain rule, but we're going to do it now. We've done it with the quotient rule. That's what I was thinking about. So if we want to take the derivative of this, let's first change this to x squared plus 8x to the 1/2 power. So we got to take the derivative of this first. So the derivative, something to the 1/2 power would be 1/2 of that something to the negative 1/2 power. And then we're going to times by the derivative of the inside. The derivative of x squared plus 8x would be 2x plus 8. All right. So what we can do is simplify this here. We can multiply the half times both of those, and we would get a, well, half times 2 is x, half times 8 is 4, and this x squared plus 8x to the negative 1/2 power would just be over radical x squared plus 8x. So here is the derivative. If we want to find or evaluate the slope or the derivative at a given point, all we need to do now is to plug in the x term. So what's f prime of 1? This is why it's important to make sure we can rewrite this. It'd be way harder to take this and answer, which we could, and plug 1 into it. It's a lot easier when it's written like this. So what is 1 plus 4 over the square root of 1 squared plus 8 times 1? So let's see, that'd be 1 plus 4 is 5 over the square root of 1 plus 8, that's 9. And so the answer here, the evaluation of the slope would be 5/3. Not too bad. Anything else? No. Okay, so let's take a look at the homework tonight and see if you guys have any questions with it. So on B. So this first problem here, very similar to the one we did, except for it should be a little bit easier. It's still the third power, but you'll have to do product rule with the chain rule. Next problem here, we'll have to do quotient rule with the chain rule. Next rule, we'll have the chain rule with the quotient rule in. And in this problem here, we have the chain rule with the chain rule with the chain rule. So this problem here, let's do 34 together just to kind of practice this. The chain rule inside of the chain rule. So we have all of this cubed. So we have the derivative of something cubed would be 3 of this something, plus 1, to the second power. And then we're going to times by the derivative of the inside. Now let's times by the derivative of the inside here. So 2 would go away. Something to the fourth power would be 4 of that something to the third power. And then we need to times by the derivative of that something. The derivative of x squared plus 1 is 2x. All right, so there's 34 set up for you. We got the chain rule inside of the chain rule. Keep going. It's like Inception. Just keep going deeper and deeper and deeper. All right, and then the next problem's here. All you're going to do is take the derivative of all those and plug in the x numbers. Should be all right with this. If you guys have any questions, just reach out and ask. If not, remember, pause the video, go back and watch it anytime you need some help. You guys should be all right. Check your answers online, and I will see you next time.